So far, we know that there is a new force that we call it electric force. And what we call as charges are responsible for this new field or force. Based on the observation that we made, we have to have two kinds of charges, which we call as positive and negative. If we put a positive charge, it creates a field around itself, which means that any positive test charge put in that field would feel a force equal to this value. The direction would be in the direction of the field lines, which means that the positive test charge would be repelled in the field that the positive charge has created. Well, the direction would switch if we instead put a negative charge. This time the positive test charge would be attracted. The same way that electrons and protons have mass, and we define a mass of 1 kilogram as many of them. In fact, protons and electrons have a lot of properties like mass, charge, dimensions, and other things. We say the mass that 10 to the power of 26 protons have is equal to 1 kilogram. Or we say 1 kilogram abstraction is the mass that 10 to the power of 26 protons have. The same way, we create an abstraction called 1 coulomb of charge. We say 1 coulomb of charge is the charge that 6.24 times 10 to the power of 18 electrons or protons have. Obviously, this means that the charge of an electron and proton are actually equal. And based on previous observations, normally an atom is neutral. When any electron moves from one to the other, the first one becomes positive since it has lost electrons, and the second one would become negative since it gains electrons. Before this movement of electrons, both were neutral because the number of their protons and electrons were equal, and also the charge that an electron and proton has is also equal. Therefore, they would be neutral. Now the question is, why would electrons move in the first place? As an example, in the comb and papers experiment, we saw some movement of electrons between the comb and the piece of cloth. Therefore, the comb would become charged. An equivalent example is the example of the balloon shared wall. As you see, right now all of them are neutral, meaning the number of protons and electrons are equal in each one of them. And we know that some material would attract electrons more than some others. Some want to lose electrons, some want to attract electrons. The reason for this would be explained later. But right now, imagine that this balloon who wants to attract electrons more, if we rub it with this piece of cloth, it would attract the electrons from this piece of cloth. So right now, the shared has lost electrons, therefore its net charge is positive, and since the balloon has gained electrons, its net charge is negative. And we know that negative and positive would attract one another. So if I let go of the balloon, it would be attracted to the shared, as you see, just like this. Now the opposite of this is when I approach it to the wall which is neutral. Well, since the net charge of the balloon is negative, when I approach it, it would repel some of the electrons in the borders of the wall. Therefore, in those places, the net charge is positive. And since the net charge of the balloon is negative, they would be attracted, or in other words, the balloon would be attached to the wall. If we rub a copper rod with the same piece of cloth, we see that it does not attract the paper. You might get the result from this observation that electrons can't move in the copper rod to make it charged. But if we do the same experiment with the glove in hand, this time the copper rod would attract the paper. The result for this observation is that the first time extra electrons in the copper rod would go through our body and to the ground, since our body, like everything else, is also made up of atoms. So it is clear that not only electrons move from material to the other, but also they sometimes move more or less depending on that material. The observation that took us here was that a plastic rod would attract the papers after being charged, and those charges wouldn't leave through our hands. We didn't need to wear gloves. So it means electrons do not move freely in that plastic rod. But for the copper rod, they could move freely. And also, obviously, it just means that they could also move in our body. Based on these observations, we categorize all materials as those that electrons move freely or conductors, those that electrons do not move freely or insulators, and those that sit in between or semiconductors, which are what we are the most interested in.